Hi everyone. Today I am going to start the Mathematics 2. The topics are differential equations, that is the first topic. So please write, all of you, the name of the subject, that is paper Mathematics 2. Of course it is engineering mathematics only. Chapter 1 or subtopic or unit 1, differential equations. Simply abbreviated as DE. DE. The full form is differential equations 2. Multiple integrals, that is double and triple integrals topic. 3. Vector calculus. 4. Fourier series. 5. Laplace transforms. 6. Complex variables. This is except civil engineering stream. So complex variables is not for civil engineering stream, remaining all having. And for electrical you have other transforms, Fourier, J transforms, and these are the main common topics. And in 2016 this is deleted. This subtopic deleted, Laplace transform for EC. Anyhow, it is usefully in mathematics. Mathematically, if you are strong in Laplace transform, then you can understand in signals and systems. For EC and electrical IN, you have one more paper, signals and systems. The transform theory you will get again. That thing. So anyhow, the last topic is not for civil engineering stream. Remaining 5 topics are common for all the streams. So now I am going to discuss, that is starting with differential equations topic, subtopic 1. Differential equations topic, and write the contents, that is subtopics. First order equations, in bracket linear and non-linear. Initial and boundary value problems. It's a small definition only. Third one is higher order linear differential equations DE with constant coefficients, comma, Cauchy-Euler type equations, next method of variation of parameters, this is not for mechanical engineering and civil engineering streams. Only method of variation of parameters subtopic is for electrical, electronics and communication and instrumentation engineering. And finally, partial differential equation. This is the last topic. This last topic is also different from streams to stream. Electronics and electrical instrumentation having same subtopic, but coming to mechanical and civil, they have some other topic for some other concept for partial differential equation subtopic. So here solution by variable separable method, except ME. ME means mechanical engineering stream, CE means civil engineering stream. Now here solution to heat, wave and Laplace's equation 2D, heat equation, wave equation 1D, and this is except or you can write not for, and this is not for EC EEIN. So I have mentioned some small subtopics which are different from stream to stream. First of all, method of variation of parameters. This subtopic, this point is not for mechanical engineering, civil engineering. Now in partial differential equation, the first definition, that is the first subtopic, solution by variable separable method. This is for everyone, not for mechanical. Okay, and this subtopic, solution to heat, wave, Laplace equation, not for EC, electrical and IN. And this complex variables, it's a big unit. This subtopic is not for this topic. Complex variable topic is not for civil engineering stream. So again, in this mathematics 2, 7 to 8 marks, minimum 7, maximum 8 marks. So generally there are many physical situations, physical problems convert into mathematical modeling, and many of these mathematical modeling solved by involving differential equations only. Okay. Now the first subtopic is first order equations. Before that, a few definitions we are going to discuss. Again, this is from 11th 12th standard only, that is definition of a differential equation, how many types, and followed by order, degree, linear, non-linear, homogeneous, non-homogeneous, initial, boundary value problems. These are the basic definition which will take maximum 20 to half an hour. Okay, if any gate questions, immediately we will do it, that related questions, gate questions also. So first of all, differential equations, in short we are writing DE. It is of two types: ordinary differential equation denoted by ODE, that is simply we are reading ODE, simply we are representing the full sentence ordinary differential equation as ODE, and instead of writing the full sentence partial differential equations, writing by short notations PDE. So this is partial differential equations. DE stands for differential equations. This is ordinary differential equation and partial differential equation. Okay, so what is the difference between these two? Just see. In calculus part, long back, that is Max 1 paper, we have two types of derivatives: ordinary derivatives and partial derivatives. So that means an equation is called differential equation, ordinary differential equation, if the differentials coefficients, that is if the derivatives are with respect to one independent variable only. A differential equation is called ordinary if it contains the derivatives with respect to one independent variable. And you know the difference between independent variable, dependent variable. Suppose if I take a derivative dy by dx, okay, so here y is dependent, x is independent. So this is an example of simple ordinary derivative representation: dou z by dou x, dou z by dou y. This is a simple representation of partial derivatives, an equation containing derivatives with respect to more than one independent variable. Differential coefficients are also called derivatives. These derivatives with respect to more than one independent variable, such equation is called partial differential equation. So mainly in this chapter, 90 to 95% problems we are finding the unknown function, that is dependent variable, which is also called solution. How do you find the solution? That means solving the problems. So after that, definitions, DEF 1. The first one is order. Okay, order of a differential equation. The order of the highest derivative present in the differential equation DE. So what is the definition? Order of the highest derivative. You know how to find, how to identify highest derivative. So what is its order? That is, if it is dy by dx, order is 1. If the highest derivative is d square y by dx square, order is 2. If the highest derivative is d cube y by dx cube, order is 3. Okay, this is the way to find order of a DE. Next, second one, degree of a differential equation DE. The power of the highest derivative is called the degree of differential equation DE, provided the dg is free from radicals and fractions as far as the derivatives concerned. Now see, while finding order, there is no restriction, just simply the highest derivative present in the differential equation. Once you find the order, that is the highest derivative in a differential equation, the power of the highest derivative, power means degree. Okay. So, in some textbooks, some others defined highest power also. Why they are defined highest power means, a differential equation has highest derivative may repeats. Say for example, dy by dx is the highest derivative in a given equation. So, it is repeated. What is repeated means, dy by dx plus 1 is equal to dy by dx whole square. So, that is dy by dx is now 2 times, but different powers. In such cases, highest power is called the degree of a differential equation. But there is a restriction, there is some condition to find the degree. What is that? Provided the degree is, the differential equation is free from radicals and fractions. So, what is radicals and fractions? For example, sine dy by dx. Sine is a function operating on dy by dx. So, sine becomes radical. Square root of 1 plus dy by dx. So, square root is a function operating on 1 plus dy by dx. So, that square root means whole to the power 1 by 2, which is a radical. X plus y is equal to y square divided by 1 plus dy by dx. So, the right side is a fraction whose denominator containing derivatives. So, that is called fractionals, free from radicals and fractions. So, there should, in an equation, if any denominator, it is containing some terms in denominator, a differential equation such that some terms in the denominator, that term should not containing any derivatives. That means it is called free from fractions. You should immediately eliminate the denominator derivatives if exist by taking cross multiplying or some other simplifications. If it is a square root of 1 plus dy by dx, that square root is called a radical example. So, how do you eliminate that square root? Squaring on both sides. Strictly speaking, that to find the degree, all the derivatives as far as the derivative is concerned, that is called all the derivatives in the given equations should be in polynomial form. What is polynomial? Powers must be natural numbers. What are natural numbers? 1, 2, 3, 4, etc. Every derivative having power natural number, then only the degrees exist. Okay. Now, before approaching the next definition, let us see a few examples. 1. This question asked in 2010, 2 marks. The order and degree of the differential equation dE d cube y by dx cube plus 4 times square root of dy by dx whole cube plus y square is equal to 0, or respectively, RESP means respectively dash. So, options given, some values, but I am not writing the options. I hope that you understand. Solution. Now, here first derivative, y square means no derivative. Here it is third derivative. What is the highest derivative? 3. Correct? So, the 3 is called order of the differential equation. So, differential equation is d cube y by dx cube, or can be written as, For order there is no simplification, but for finding degree you should eliminate square roots, cube roots, etc. These called radicals. Sine function operating on any derivative, e to the power dy by dx, exponential is a radical, and denominator containing any derivative you should eliminate, then only we can find degree. Okay, so what I am saying, differential equation dE can be written as directly. Shift this second term to the left side, is equal to minus 4 times square root of dy by dx whole cube plus y square. Next, squaring both sides. We get the left side is d cube y by dx cube whole square, right side is 16 times dy by dx whole cube plus y square. Now here no radicals and no fractions as far as the derivatives concerned. Okay. So this is free of radicals and fractions as far as the derivatives concerned. Okay. So therefore highest derivative is third derivative, order is equal to 3 and degree. So this is the only highest derivative, its power is 2, degree is equal to 2. Second example, find the order and the degree of the differential equation dE d square y by dx square is equal to e to the power dy by dx. So I hope that many of you have done. So anyhow, I am doing the solution. Differential equation is, the left side is one term d square y by dx square, right side is one more term e to the power dy by dx. So this exponential operating for first derivative dy by dx. So that exponential e is called now radical. If possible, eliminate that exponential. So many people, many students here doing some silly mistakes. To eliminate exponential, generally what we are doing, taking both sides logarithms. If you do like that, logarithms, this power will come down, log e value 1, and this left side becomes log d square y by dx square. So that log is again a function operating on d square y by dx square. So we cannot eliminate. That means here we cannot bring this differential equation into free of radicals and fractions. Okay. So here order is equal to 2, second derivative, but degree is equal to not defined. That means is equal to means is, degree is not defined, because this is not a polynomial representation, polynomial form as far as the derivative is concerned. Exponential is not a polynomial. Polynomial means all powers should be natural numbers 1, 2, 3, 4, etc. That is positive integers. Every derivative should occur the power as natural number 1, 2, 3, 4, etc. Then only we can find degree. Now the next definition is 3, linear and non-linear. A differential equation dE is said to be linear if the dependent variable and its derivatives have degree 1 only, and they are not multiplied together. Otherwise, the dE is called non-linear. Now, you know how to identify a dependent variable and independent variable, which we have learnt in derivatives long back, Max 1 paper calculus. And today also I told you a form, take a derivative, first derivative dy by dx. So, if I take dy by dx, here for which variable we are finding derivative? For y we are finding derivative with respect to x. So, y is a function of x. So, that is why y depends on x. So, that is why y is dependent variable, x is independent variable. If I take du by dt, for which term we are finding derivative? U variable. So, u becomes a function of t, that is u is dependent on t, that is u is dependent variable, t is independent variable. So, this is the way to identify which is numerator, I mean which is dependent, which is independent variable. Okay, as far as the derivative is concerned, strictly numerator variable is dependent variable, denominator variable is independent variable. Okay. Now, so please identify the dependent variable and its derivatives in the given differential equation. They must containing the power 1, that is they have degree 1 only, and these are not multiplied together. What is these are not means? A dependent variable should not multiply any one of the derivatives in the given equation. First derivative should not multiply second derivative. Similarly, second derivative should not multiply any other derivative. That is called these are not multiplied together. Okay. So if this condition is satisfied, then only the differential equation is called linear, otherwise it is called non-linear. Okay. So let us see few examples. We can say directly linear or non-linear by using the above definition. 1. X dy by dx minus 3 into y is equal to x square. So as far as the derivative here dy by dx, y is dependent variable, x is independent variable. So y power 1 dy by dx whole power 1. So y dy by dx having power 1 only and are not multiplied. So I can say this is linear equation, but highest derivative is 1. So first order linear equation in which variable? Y variable. Okay. So because y is dependent, is a first order linear equation in y variable. Okay. So just this is called FOLE. First order linear equation can be written as in short form FOLE. FOLE abbreviated as first full form, a first order linear equation. Okay. So this is main in y. 2. D square x by dt square plus 6 dx by dt plus 8x is equal to e to the power minus t. Here as far as the derivatives, x is dependent, t is independent. X power 1, first derivative dx by dt having whole power 1, second derivative d square x by dt square whole power 1. So all are having power 1 and no two of these multiplied. That is, x is not multiplying any one of the derivatives. Similarly, any derivative not multiplying other derivatives. So is a second order, highest derivative is 2. Highest derivative is second order derivative. Second order linear equation in which variable? X. X is dependent. Okay. So here y is dependent and x is independent variable. Independent variable. Similarly, in this second example, here x is dependent and t is independent variable. So for some students' purpose, I wrote which is independent, which is dependent also. Okay. Next, 3. D square y by dx square y d square y by dx square minus dy by dx whole square is equal to 0. Here, as for all the derivatives, the numerator variable y is dependent, the denominator variable x is independent. So y power 1, first derivative having whole square, so it is called non-linear equation because the power of the first derivative is 2. I told you all derivatives having degree 1 only. Okay. Now, and moreover, dependent variable multiplying its second derivative also. So highest derivative is 2, but it is a non-linear equation. So this is a second order non-linear equation EQ in y. So here y is dependent variable, x is independent variable. And the fourth definition is homogeneous and non-homogeneous differential equation. A differential equation dE is said to be homogeneous, if each term contain either dependent variable or its derivatives. Otherwise, the dE is called non-homogeneous. So, every definition related to dependent variable and derivatives only. So, in the given equation, every term contain either dependent variable or derivatives. Its derivatives means dependent variable derivatives. Say y is dependent variable. What are its derivatives generally? dy by dx, d square y by dx square, etc. So, every term must contain either dependent variable or derivatives, otherwise it is called non-homogeneous. Example, this question asked in 2014. Which one of the following is a linear, non-homogeneous differential equation where x and y are the independent and dependent variables respectively? Question mark. A. dy by dx plus xy is equal to e to the power minus x. B. dy by dx plus xy is equal to 0. C. dy by dx plus xy is equal to e to the power minus y. Option D. dy by dx plus e to the power minus y is equal to 0. So, here we are not solving, but we are saying according to the question linear non-homogeneous. So this is linear. Two definitions there. We know linear meaning a dependent variable and its derivatives having degree 1 only, no two multiplied together. That means, and they are not multiplied together. Non-homogeneous, homogeneous also you know. Homogeneous means each term containing a dependent variable or derivatives. Otherwise it is called non-homogeneous. Now see option A. Solution. dy by dx plus x into y is equal to e to the power minus x. Now he already mentioned y is dependent. Y power 1, its first derivative having whole power 1, dependent variable y and its derivative not multiplying. So this is a linear equation, first order linear equation. Coming to the homogeneous, non-homogeneous, first term, second term, third term, three terms. Each term must contain either dependent variable or derivatives. First term containing a derivative, second term containing a dependent variable. The right side, the term e power minus x not containing a dependent variable or derivatives. So is a linear and non-homogeneous equation. Because the right side e power minus x is not containing any y variable or its derivative, dependent variable or derivatives. That's why this is non-homogeneous. Okay. Similarly, you can, so answer is option A. But what is option B? dy by dx plus x into y is equal to 0. So this is a linear but homogeneous, just like matrices, homogeneous and non-homogeneous equations. Okay. All variables on the left side. If the right side zeros, then it is called homogeneous system. Otherwise it is called non-homogeneous system. So this is homogeneous equation as well as linear. Is a linear and homogeneous equation. Like that you can go through that other options also. But anyhow we got the answer is option A. Have a break. If you have any doubts, please post the questions in detail.